works for a right triangle. So a triangle with one right angle. A and B just represent the legs of the triangle. It does not matter which is which. The key to this is C is the hypotenuse. And so if you have a 90-degree angle, then you know A squared plus B squared does equal C squared. All right, let's use that and look at a few problems. So C is just always the hypotenuse, the longest side, the one across from the right angle. A piece of property shaped as a right triangle. So right now, what should you do? Draw a right triangle. Okay. With the longer leg, my triangle doesn't really have a long leg and a short leg. I'm going to alter my triangle a little bit. Make sure one side looks longer than the other. There we go. Is 10 meters shorter than twice the other? Okay, so this is describing the long one. So do I know how long the short one is? What should I call it? X. Okay. 10 meters shorter than. What does shorter than mean? Minus. Is it 10 minus or minus 10?
Minus 10.
Twice the other. So twice would be 2x. This is on it. The hypotenuse is 20 meters longer than the longer leg. Okay, so the longer leg is my 2x minus 10. 20 meters longer than that, what would we do? Add 20. If you want, you could simplify that. It comes out to be 2x plus 10. If you add your negative 10 and positive 20. All right, my directions are just to find the lengths of the legs. My triangle is set up from here. It's a right triangle, so I know A squared plus B squared equals C squared. So A and B are just the legs, so I would have an x squared plus a 2x minus 10 squared. C is the hypotenuse, 2x plus 10 squared. How am I going to square 2x minus 10? FOIL. It means you have two of them if you need to write that out. So we have x squared plus, if I FOIL that, we get 4x squared minus 20x, minus 20x. Can I just go ahead and write minus 40x? Everybody knows where I got that. Negative 10 times negative 10 is positive 100. On the other side, if I wrote that twice, you would get 4x squared plus 20x and plus 20x plus u is plus 40x. 10 times 10 is 100. What do you want to do now? So this is a quadratic. Our strategy with quadratics is to set them equal to 0. So if I subtract my 4x squared, 5x squared minus 4x squared would be 1x squared. Subtract my 40x, so negative 40 minus 40 would be negative 80. What happens when I subtract my 100? Those cancel. Okay, I only have two terms here, so I can't do box method, but what could we do? We could do the quadratic formula. That works, or there's an easier way. Yeah. So if you set each to 0, we get 0 and positive 80 for our answers. Now, can you draw me a triangle with a side length of 0? No. So for us, that doesn't work. So the 80 is my answer. How do I want you to answer these? sentences. The question was for the lengths of the legs. So one of them was x, so that would just be 80. We were in meters. The other one, 2x minus 10, so 2 times 80 minus 10 would be 150 meters. Any questions right there? A boat is being pulled into a dock with a rope attached to the boat at water level. When the boat is 12 feet from the dock, the length of the rope from the boat to the dock is 3 feet longer than twice the height of the dock above water. That's a lot. What should I do? Draw a picture. Okay, so let's see. I am just so artistic. So here's the dock. And you know, docks sit above the water, right? So my water's down here. And then I've got a boat sitting in the water. Okay. So, beautiful artwork here. And now we have a boat being pulled in. It says a rope is attached to the boat at water level. So there's essentially a rope going from the dock to the base of this boat. When the boat is 12 feet from the dock, where would that be in my picture? Is that the hypotenuse, the vertical, or the horizontal? Okay. The length of the boat, of the rope from the boat to the dock is 3 feet longer than twice the height of the dock. Do I know how tall my dock is? So that would be x. 3 feet longer than, what does that mean? Plus 3, okay. Twice the height of the dock would be, so this side is 2x plus 3. Alright, why don't you guys try to set up your equation and finish it for me. Right, what did you guys do first? Quadratic formula. You have to remember that 2x plus 3 is the hypotenuse. So a squared plus b squared equals c squared. So that's x squared plus 144. Over here you have to write that twice and FOIL it, and you should have gotten 4x squared plus 12x plus 9. Everybody okay there? Set it equal to 0, so if I subtract over my x squared, that's a 3x squared. Subtract my 144, so that's negative 135. What could you do to all of these numbers? Take out a 3. If I divide by 3 on both sides, now it'll just give me something smaller to work with, and I have x squared plus 4x minus 45. Factor, because it's a 1x squared, we can do the shortcut. Multiply negative 45, add to positive 4. Negative 5. Set those equal to 0. You get a negative 9 and a positive 5. Are both of those options? X represents the height of the dock. Can you go build a dock with a height of negative 9? I mean, I guess maybe if you build it underwater, 9 feet below water, but that wouldn't be very useful to you. So we just need the positive here. Do you have a question? Sorry. Then we have to answer the question. It was just the height of the dock. And we were in feet, so 5 feet high. Questions? switch gears just a little bit. There's a problem very similar to this on the Map Excel. And I wanted to run through it and make sure we knew what we were doing. So a farmer wishes to enclose a rectangular region. He has 120 feet of fencing and plans to use the barn as one side of the enclosure. Let X represent the length of one of the parallel sides of the fencing. Part A, find a function representing the area of the region. Let's start out with a picture. So he's got the barn over here, and he's building the fence off the barn. So no fence is going on that side. Did I give you any information about the lengths of these sides? Okay. Let's see if we can figure out something. If I called this one X, I know this one would also be X. But this side could be different. If I called it Y for a moment, we know that we can't have both X and Y in a problem. But I did tell you something else. How much fence does he have? 120 feet. So basically, if you add those together, X plus Y, that has to equal 120. Could you get the Y by itself? What would you do? So that other side is the 120 minus 2X. Another way to think of it, if you have 120, you have to take X off for each of those sides, so you have 120 minus 2X left. Okay, I want a function for the area. How do you find area? Length times width. So if I distribute it, I get 120x minus 2x squared. Are we okay with that one? Part B, what are the restrictions on X? I'm asking you what numbers does X have to fall between? What does that have to be bigger than and smaller than? If X is this length, it has to be bigger than what number? 0. Okay. Could X be 100? Seems reasonable, right? But if I made both of those 100, this side would become 120 minus 200, and that's a negative, so that wouldn't work, would it? What would make this side equal 0? That means if X is 60, this side turns out to be 0. Now, in practicality, would that make any sense? No. But we know it certainly can't be a negative, so the biggest it could be is 60. Now, I didn't put equal to there because you can't actually build a fence with a side of 0. But I'm saying it has to be some number between 0 and 60, so that neither of those sides has a negative length. Does that make sense? C. For what values will the area be between 1,600 and 1,750 square feet? Now we could do this two ways. We can do it by hand. We'll have to find out when it equals each of those things and then interpret our answer. But remember, we've done some with the graphing calculator, haven't we? So let's use that to help us. Okay, I want you to go to your y equals. The first thing I want to enter is this equation for my parabola. The 120x minus 2x squared. For my y2, I'm going to put 1,600. going to go ahead and enter my Y3, 1,750. Now, if you just look at this graph from -10 to 10, is it going to show me anything? No. Let's go to our window. Does everybody have these three things entered? Okay. So my window. Is X going to be a negative? On part B, what do we say about X? It has to be between what and what?
0 and 60.
Alright, so let's make my X min 0, my X max 60. Y min. I am really interested in this thing between 1,600 and 1,750. So I just need to get things between those. So I'm going to say my Y min maybe 1,400 and my Y max 2,000. It's not going to show me the whole graph, but it'll show me what I want in there. You can change your Y scale if you want. We've got some pretty big numbers. I'm just going to change mine to 100. It'll just speed up my calculator a bit. And then let's graph. So there's my parabola. There's the 1,600. And there's the 1,750. Did everybody get this? Okay. Now, I want to know when it's between those. And it happens twice, doesn't it? This section's between them, and this section is between them. So we're going to have to write answers for both of those. Do you guys remember how to find where graphs meet? We went to second, trace, intersect, number 5. Okay, first curve it has up here, that's my parabola, just hit enter. Second curve, you can see mine jumped down to my 1,600 line, that's what I want, hit enter. Guess I'm going to use my arrow to get over to this point and hit enter. And it tells me at the bottom, what is that X value? 20. So it's between 20 and, now I need to find out where the black line meets my parabola. So I'm going to do the same thing. Second, trace, intersect. First curve is still my parabola, but do I want my second curve to be this red line? Just hit your down arrow, and that'll make it jump up to the other line. Hit enter. Yes, get close to it and hit enter. And that one is 25. So, for what X values is the area between this? It's between 20 and 25 feet. Or, we saw it happened again. So now I need to describe the other one. Does anybody need help with their calculator at this point? Which one are you doing? First one or second one?
First.
Okay. Good. Check it. Your second curve. First curve is your parabola. Second curve is the line. Yes. And then I did it again. First curve is parabola. Second curve, I just done 1,600 back to this one. I just hate it down here. Okay. First curve, second curve. First curve is the parabola, and the second curve, I don't want this line, I want that one. So if you figure down here. And that one's just- Anybody else have any problems? Okay, let's find the other set of points. Which one do I want to find first, where it meets The black or the red line? Let's do the black one because that's going to happen sooner. So second trace intersect. First curve, it's going to my parabola. It tells you at the top which one it's on. Second curve, it jumped down here. Is that the one we said we were going to find? No, so just hit your down arrow. It'll jump up. And I want this point over here, so I'm going to move my cursor over for my guess. And that one is at 35. Everybody get that? Okay. One last time, we need to find where the parabola meets the red line. So second trace intersect. First curve, it's on the parabola, hit enter. Second curve, it jumped down to my red line, which is what I want, hit enter. Guess, get close to your point, hit enter, and that is 40. So if you pick any number between 20 and 25, or between 35 and 40 for your x, you will get an area that is between 1,600 and 1,750. Okay, so we can use our calculator on these problems if needed. C, what's the maximum area that can be enclosed? Anytime I ask about a maximum or a minimum, what am I asking you to find? Vertex, opposite of B over 2A. So my B value here, go back here. The B is the coefficient on x, so that would be a 120. Over 2, my A is the x squared coefficient, so that's -2. Okay, keep in mind, this is the x value. What do you need to do with that? Plug it in. So if I put that into my equation, I get 1,800. So the maximum area, that would be the y, that's the 1,800 square feet. The dimensions, that's talking about the length and width, so that would be my x, which was 30 feet. My other side, 120 minus 2x, so 120 minus 2 times 30 would be 60 feet. So really, it's still asking you questions about the vertex, but I threw in a piece using the graphing calculator like we have done in the past. Questions there? The next two examples, they're kind of optional. It's nothing new, just stuff that we've done. Do we need to do another graphing calculator practice problem, do you think? Okay, let's do at least the next one. If a projectile is shot upward from the ground with an initial velocity of 73.5 meters per second, neglecting air resistance, its height in meters above the ground is given by this equation. So really the only important piece here is this, knowing that S is representing our height and T is the number of seconds. Part A, what is the height after 2 seconds? What do you have to do? Plug in 2. So that means my height is 127.4 meters. Part B, after how many seconds will the projectile be 100 meters above the ground? Where do you put the 100? For the S. Okay, we have options. We can set this equal to 0 and do it by hand, like a quadratic formula, or we can use the graphing calculator. What do you guys want to do? Calculator. So, go to your calculator. We are going to enter each side of this equation as a separate y value, so clear out what's there. I'm going to make my y1 the negative 4.9, you have to use an x squared, plus 73.5x. And then my y2 is the height I'm looking for, which is 100. Alright, let's adjust our window. My x's, I don't really know what kind of x value we need. Let's leave those for a minute. Let's make our y min 0, and our y max, we're going up to 100, so let's make it 150. And I'm just going to count by 10. So my y min 0, y max 150, y scale 10. It's not necessarily a right or wrong, but I'm just trying to get a window that'll show me what I need. Okay. Certainly doesn't show me the entire parabola, does it? But it shows me what I need. Okay. If you don't like this window, if you're not sure what you're looking at, you can go back, maybe make your x's skinnier if you think you're seeing too much. Maybe we just want to go from 0 to 10. I don't know if that would show us. Let's look. So you can play with that window and adjust it as needed to see what you want. If I just went from 0 to 10, does that show me enough? No. So it's a trial and error. You don't always get it right the first time. You might have to go in and adjust things. But ultimately, we just need to be able to see both sides of the parabola and that it hits that line. Now I need both of these intersection points because I want to know when the projectile is more than the 100, so I'm looking for this section right here where it is above. So you are going to go to your second, trace, intersect. First curve, it tells me it's on the parabola, hit enter. Second curve, it's on my line, hit enter. Guess, I'm going to do the first point. Hit enter. And I see that intersection is at 1.51 seconds. Second one, do it again, so second, trace, intersect. First curve, enter, second curve, enter. And now we need the second point over here. Hit enter, and that one is 13.486, so 13.49 seconds. So we're just using the calculator to solve some of the easier problems. Part C. How long does it take to return to the ground? If it returns to the ground, what's your height? 0. So we could do this on the calculator. Do we have to? No. This is a pretty easy one to solve by hand. What would I pull out of here? T. Set each one to 0. Solve. So I get 0 and 15. The 0 is when we started, so how long does it take to return to the ground? 15 seconds. You could have also done it like we did part B. You would just make your y2 a 0 and find the intersection. Last question, maximum height. If I ask you about a maximum or minimum, what am I asking you for? Vertex, opposite of B over 2A. My B was 73.5. A is negative 4.9. If I plug that in, I get 7.5. Is that the height? No, that's like our x, or in this case, that's our time. It takes 7.5 seconds. To find the height, you plug that in. I'll get a maximum height of 275.625. We were in meters this problem. Okay, so lots of these are just asking maximum and min. That's always your vertex after the over 2A. I do not think I'm going to do the last example because it's just more practice with finding the vertex, and I want to give you guys time to work on the homework. So we're going to skip that one. The Math Excel is open, so I would like for you to take this time to work on that and let me know if you have questions.